Let's look at the other basic parameters of air quality modeling. Like I mentioned before, there's three aspects of it: engineering, meteorology, and GIS, or the surface characteristics. Now, the engineering aspect involves the emission characteristics of the stack. You need to know how to quantify the emission in grams per second or mass per unit time. So the characteristics of the stack or the source are the emission rate, how much does it emit the pollution from that source, the height of the stack, the width of the stack or the width of the area, etc. And we also need to know the location of the stack, the geographic location or the coordinates, and this one requires you to use some GIS to pinpoint the location of that stack or the area on a map. Then there's the meteorological characteristics, which involves both GIS and meteorology. GIS is the surface characteristic part. We need to know what is the characteristic of the surface in which the plume travels over. So the characteristics of the surface includes the albedo, bone ratio, and surface roughness, because these three parameters also affects the temperature profile. I think you've heard of albedo. So if albedo is low, it will absorb more heat, so the surface tends to be hotter. The albedo is high, then it absorbs less heat, so the surface tends to be cooler. So these characteristics affect the surface, which affects the temperature profile. Bone ratio, so you know it's a ratio between the sensible heat over the latent heat. And that also affects the temperature profile. How unstable or stable the atmosphere is. And the last surface characteristic is surface roughness. So if the surface is smooth, then you can see the wind profile to be like so. Somewhere at the bottom here, the wind speed is 0 at the surface, but as it goes up, it becomes larger and larger. But then if on the surface there are buildings or there are trees, it becomes rougher, so that the height of where U is 0 is somewhere on top. And this also introduces some turbulence into the flow, which also affects the temperature profile or the stability of the atmosphere. So we need to know these three basic parameters of the surface to relate to the temperature profile of the atmosphere, so that we can guess the dispersion of the plume. Then besides that, you also need to have some data on terrain, because here we say that it's flat, but there are also some inundations over the surface that changes the Z coordinate. Just now the Z coordinate is like that. So sometimes the Z coordinate is above here. Maybe this is 0 at Z equals to 0, it means at sea surface level. But then maybe if you're in a mountain, so the Z coordinate becomes different. And then if the stack is here, so maybe here is low, but here will be high, because it's right in the middle of the plume. So you need to know this as well, the terrain. The atmospheric surface layer that is above the Earth surface, the bottommost layer. So the characteristic of that bottommost atmospheric layer. But this is for more advanced air quality models. We need to know the temperature profile in this layer, the boundary height of the layer, how high is that boundary layer, how high is the surface layer, and so on. But the most basic air quality models, we don't need to use the upper air characteristics.